Okay, guys, we are now onto a tangent curve. So the first thing I want you guys to notice is that this could be a cotangent curve if we just had to do a reflection. The difference between a cotangent and tangent curve, if you remember correctly, is really a cotangent curve is a reflection of the tangent curve with a phase shift built in. So we're going to start with the tangent curve first because this one, the way it's actually leaning, does look like a tangent curve. So the first thing we want to notice is where are the vertical asymptote located. So I can clearly see from this graph there is a vertical asymptote at x equals to negative pi and at x equals to pi. That tells me this particular tangent curve has a period of 2 pi, which is double of the original period of tangent, which is a pi. So that tells me there is a coefficient that needs to go in front of my x. Now, since it is a horizontal stretch almost by a factor of 2, that means that coefficient that needs to go in front of my x value is 1/2. The second thing I want to notice is that it doesn't go through 0, 0. So that means there is actually a vertical shift that has happened. To determine what the vertical shift is, we kind of have to go back to the idea of what a tangent curve looks like. So if you guys remember, the tangent curve, when we did the table of value, it's made up of 5 x values. We start at negative pi over 2. The center is at x equals to 0 and it ends at pi over 2. Now on the two sides, we also build in 2 additional points. One is negative pi over 4 and one is at positive pi over 4. So if you think about the location of negative pi over 4, it is actually in the halfway between negative pi over 2, which is the vertical asymptote, to x equals to 0, which is the center of that particular tangent graph. So in that idea, if I have a vertical asymptote at x equals to negative 2 pi, and I have another vertical asymptote at x equals to pi, that means there is a center for this graph at x equals to 0. And since the other 2 point needs to be located at the halfway point between the vertical asymptote and the center of the graph, that means the halfway point will be negative pi over 2 for this half. Now, if I take a look at negative pi over 2, they gave me the point here. They're very nice about that. I have a point at negative pi over 2, comma 2, and another point at pi over 2, comma 6. So if I look at my center, which is at 0, 4, it's safely to assume that there is a vertical shift up 4 units, which means I need to do a plus 4 in the back of my equation. But I also notice, if you think back to the original table value for the parent function of tangent x, the point goes negative 1, 0, 1. They're 1 unit apart. But if I notice here, this has a y value of 2 and this one has a y value of 6. That tells me there is a vertical stretch by a factor of 2, because to go from 2 to 4, you actually have to go up 2 units, not just 1. Okay, so we determined there is a period change. We also determined there's a vertical shift and there is a vertical stretch. Is there a phase shift? Well, if I think my center is 0, 4, which I do think my center is 0, 4 here, because it is x equals to 0 is in the middle of x equals to negative pi and pi. If this is my center, then there is actually no phase shift because my graph didn't go left or right. My center didn't shift left or right. It's still staying at x equals to 0. It just went up 4. So with all that information, we're actually ready to write the equation. First of all, there is no reflection across the x-axis because my graph is still leaning to the right. So we're going to do a vertical shift of 2. And again, that's not amplitude because tangent and cotangent has no amplitude, if you guys can remember correctly. Amplitude is defined as the distance from the center of the graph to its absolute max or min. And since tangent and cotangent doesn't have max and min, that's the reason why there is no amplitude for tangent and cotangent, and secant and cosecant for that matter. So this is tangent, and we already said our period went from pi to 2 pi, which means it doubled. But since the actual formula to find the new period is the old period divided by whatever the coefficient is, which is the number I'm about to type in, and pi divided by what will give me 2 pi? Well, pi divided by 1/2. So this is going to be 1/2 x. Let me put this in as a fractional form. Okay. 1/2 x. And again, we already established there is no phase shift because my center is still at x equals to 0. But there is a vertical shift up 4. There you go. So there is my tangent graph. Okay. Now, I promise we're going to write it for cotangent as well. So here we go. We're going to copy all the information over because again, the difference between tangent and cotangent is a reflection plus some phase shift. So the vertical stretch and the period will still be the same. So now we have to determine how we're going to do the rest of this. Okay, so there's still a vertical shift of 4. There's still a vertical stretch by a factor of 2, and there's still a period change of 1/2. But there is a reflection because cotangent actually leans towards the left. So this should have been a -2, not a +2. Also, if I remember cotangent curve have a vertical asymptote at x equals to 0, which I don't have it here. My vertical asymptote is actually at x equals to pi or x equals to -pi, which tells me I could write this both as a phase shift to the left pi or to the right pi. It really does not matter at this point. So I'm going to choose to the right. Well, maybe I should choose to the left because everything is so positive right now. So let me take the 1/2 out of my parenthesis. Okay, we're going to say x plus pi, which explains how my vertical asymptote went from x equals to 0 now to x equals to pi. But remember, my period change still stayed. There's still a period of 2 pi here, so I still need to add the 1/2 back on. Okay, type in the 1/2. And that completes it. And again, if I need to check out my answer, I can always put this into my graphing calculator in radian mode and check all the points. Also, if you want to check to see where the vertical asymptote is, because sometimes on the graphing calculator you can't see that very clearly, I would suggest you going into the table function and make sure you set your mode to asking instead of automatic. That way you can put in the value that where you assume the vertical asymptote is going to be. And if the vertical asymptote is there, your table should show a y value of undefined or do not exist. So that's how you're going to check to see what is happening and where your vertical asymptote is going to be. And again, if you have questions, make sure you ask me, I'll remind. All right, bye guys. Good night.